Hi, everybody. I'm Henri, co-founder of OKcontract, and today we're going to talk about universal frames at the interaction between developer tools, developer experience, and UX as well. There are about 500 million people worldwide who hold cryptocurrencies. But if we look at the stats, at the Dune dashboard, etc., only a tiny fraction of them actually use contracts. If you look at Lido, for instance, there are 300K users. That's 0.05% of the cryptocurrency holders. If we look at Aave, which is the most used, let's say, non-staking DeFi protocol, it's about the same. If we combine the statistics on all chains for V3, the latest version, it's still 300K users. And if we look at Uniswap, which is the most heavily used dApp and smart contract, it's 0.3 million users, more so 0.5 according to different estimates. Why? Because we have limited distribution channels. If we look at Ethereum.org website or dApp Radar or several dashboards, basically, they tell you that we have 12,000 decentralized apps. But there are way more distribution channels. There are 4 million mobile apps and almost 2 billion websites. So the question is, how do we extend the reach? And if we look at what Frames achieved, basically, for Farcaster, they added interaction and showed what it is to attract third-party developers, putting interaction with smart contracts inside their application. But it's still one app. And it contributed to their growth, but as we see with the numbers, the growth is still limited to the potential of 2 billion websites and 4 million mobile apps. So the question is, how can we generalize this? How can we have universal frames that go way beyond? And there is a second problem. The second problem is that most frames are limited to very simple transactions, like a free NFT mint that has no parameter. It's something very easy to build. And the gas also is often subsidized by your paymaster, so you can have fully empty wallets interacting with it. But the real life, we want more transactions that involve actual users, actual wallets. And also here in that case, the transaction is built by the frame server, which introduces a centralization in the whole architecture. So as we were telling, frames don't solve transactions. What they solve is display, because basically the actual transaction that you send in the frame is just the raw call data, the raw bytes of it. We are not solving the way we implement these transactions. There are frameworks as well, frameworks. But they still don't help. Like they add just a few layers by converting the parameter using the ABI so that we are building the call data. So that's a single step, but it's way insufficient to reach what would be a global way to interact with smart contracts. What we want is enabling contract interaction across all applications to reach users everywhere. So we go from siloed dApps, like we have today, which is more or less Web 1. Web 1, banner, click, go there, and you'll go to a dApp. But we want what Web 2 has achieved, like Stripe, for instance. You don't go to Stripe website to do a payment. You stay where you are. And this is what we want to interact with smart contracts, integrated experiences. But to do this, the problem is it requires way more front-end. So how do we scale front-end development so that we can integrate these smart contracts everywhere? And I won't go into details in this short talk, but there is a lot of friction, and the key takeaway is front-end development done well is way harder than it seems. If we look at one example, Uniswap v3, which is the most common interaction, by the way. The most common interaction on-chain is to swap ETH to USDC using Uniswap. So let's take this as an example. If you look at the React code base, there are hundreds of hooks, hundreds of files, and thousands of lines of code to manage it properly. Because of the architecture of the contract, you need another contract, a quoter, to get a quote, and then take this code, do computation with it, to integrate slippage, and then resubmit another transaction with all these build arguments. And this becomes more complex. You need more than one ABI, you need a lot of things, manage big numbers, etc., etc. We need a shortcut. And the shortcut is, to what we found out, an automated tool to create these contract interactions and an SDK to embed these interactions into multiple front ends. And as well as one thing that I won't dig in today, which is a network, a decentralized network to handle this interaction without centralization parts. So this is the simplest way. We start by defining what an interaction on-chain is. We have one single SDK to integrate it, and then it runs everywhere, because the runtime as well matters. How do we need to manage from all this front end, the RPC nodes, some private APIs, which in the case of frames is the frame server, because behind each frame you have a frame server, which is usually an AWS instance. So we solve it by building a first part, which is what we call a kind of hub, so a GitHub if you want, for interactions, a way to create, clone, experiment with contract interactions. And as you'll see, it will be community-centered. So instead of writing hundreds of lines of code, what we introduce is a concise specification for any interaction. Okay, how do we do this? We do this by introducing a new programming language, which won't be too much visible. Can be GUI tools that make it easy for some developers. Otherwise, you can dig into it. It's a real functional programming language, which has many features like abstract RPC calls, the addresses, the contracts are first-class values in the language. It's strongly statically typed, and this helps a lot with making sure that the specification we have of the interaction is correct, and it can be very easily audited. And to start with, because of the size. And as you see, it's very, very concise. And then it will be compiled to a functional reactive runtime, which runs in a VM inside the browser or later the mobile. And the community part is there to make it permissionless. There's attestation, so we worked with EAS, Ethereum Attestation Service, to design a way to attest for the interaction, the contracts, but this will be for another talk. Just look at one real example, the most common one. How do we swap ETH to USDC on Uniswap v3? And this here is the complete specification of the interaction. You'll see, for instance, that we interact with another contract, which is the Uniswap quota v2, which is defined in the graph database, which is behind OKcontract and which is decentralized. And all the computations that we will do, including the slippage computation, is expressed here. The big numbers are native. There's no need to specify these computations manually. The tokens that we interact with are also defined, and we check that the whole graph is verified when we compile the interaction. There's nothing more. And how do we integrate it? And that's the second part. Once you have defined your interaction, which lives in the network, a decentralized network, and signed by wallets and stored on chain, then you just need to integrate it. And this is something that we think is for the first time a SDK really made for front-end developers. We talked to a lot of front-end developers. Many come from a UI, Web2 background, and they have a hard time managing the complexity of the libraries in the ecosystem, like Ethers, Web3, Veeam, etc., which involves a lot of complex concepts. Here, basically, you'll see that this is 6 lines of code. We just use OKcontract, a global class which manages the wallet connection, the RPC connections, OKinstance, one per page, which basically holds a cache of the value, so we speed up the navigation, and OKWidget, which is a React component, which basically takes one ID, the ID of the specification of the interaction, and renders something. That's the something. The something is a fully auto-generated UI, which is foolproof for front-end developers. It's just 6 lines of code. And end users can as well verify the interaction because of the link in the bottom left, which leads to a verification page on-chain proving that the specification is correct, the attestations, etc., etc. If you want to play with this 6 lines of code, but the whole project setup is github.com, OKcontract, Uniswap demo. Many people ask us then, oh yeah, but we also want to customize these interfaces. For that, we have another component called OKinteraction, which basically exposes the whole state of the wallet connection, the RPC, the transaction lifecycle, the build information text, build button text, etc. Everything is exposed as cells, which is based on our own library. As you see here, there's no dependency but React and the OKcontract SDK. There's no other library that you need. You just go this time in OKcontract, the same global instance for wallet and RPCs, OK instance, one per page, and then the OK interaction with our custom app. And this can lead, for instance, to this kind of customized UI, which differs from the previous one because here we manage everything by hand, but this is meant for a front-end developer. So basically, there's no complex computation whatsoever involved in this. And you can do your own app level, any interaction you want. And if we look at all the state parts that we use, they're here. So basically, we define, for instance, that we want the wallet, we want the name, so the ENS name. We want to see if it's verified, if there has been a signature by this user yet. The stepper, which involves multi-step transactions, so like approve, a swap, and then maybe a third transaction even to stake, and many, many other things. They're defined in the doc, of course. And you can perform actions extremely easily. You just say, oh, I want to connect to the wallet, or instead drop the connection. I want to send this current transaction. I want to know how many transactions there are in this interaction. I want to switch to the desired chain for this. This is extremely easy, and it will be just a few lines of code. Just to give you an idea, if we go back to this, the complete example, including all the React boilerplate, etc., is 120 lines of code. And no dependencies. We can do a short 30-second demo of what it looks like for 120 lines of code, fully included, including the import React, etc. So as you can see, I can sign here with my wallet. I have the ENS name. It reacts. I can't swap when the amount is 0. Then the transaction is being sent. The Explorer link is shown immediately, and it points to Ethcc. And then in about 15 seconds yesterday, the block is mine. And when the block is mine, you get, for instance, the block number, which is just to prove that we received and we are communicating with the app. So all this is 120 lines of code, nothing else, and with complete customization of the UI, but not a single complex detail of the interaction. How do we move out of this? No, now it's played again. Okay. So it can as well manage multiple steps, including, of course, the approvals, which are, and that's a bonus, automated as well. This demo, the compound one, is github.com, OKcontract compound demo. So, what have we done? Here, basically, it's one specification. And I just show here the one front end, which is a web app. But we can put this in multiple web apps, of course, but it's not limited to web. It could be a landing mobile page, and we are now working on integration, on direct integration with Discord and many other social media types, and this is something that we'll share pretty soon in the next few months, but we have a pretty awesome demo with Discord where we can put any kind of interaction we specify into Discord, and it works extremely well. We think that this can be really the future of contract interactions. Any front-end developers can embed these numerous smart contract interactions into their apps. What was it? And any smart contract developer will be able to distribute their contract to third-party apps and websites. When you have partners, a partner writes a blog about your project. Basically, they can integrate the transaction with your smart contracts into their blogs extremely easily. So these embedded experiences anywhere, so as I said, it's blogs, documentation site, website, news, social media. There's really no limit to what we can do. And this is what we can call universal frames, basically. Universal transactional frames, it's interactions, experiences that you embed everywhere. So we fully support EVM chains, and we are also working with Starknet, and Starknet support is coming real soon. Thank you. So if you want to follow the pointer, you can follow us on, of course, X. Thanks a lot for that. And if you want to follow myself, I'm Henri __, okay? We have a Telegram group where we'll open the communication as well. And of course, the GitHub, the demos. And one minor thing that might interest some of you is the cells. So the reactive functional programming library that we have built is already being used outside of the Web3 crypto space. And yeah, I'll also speak about this at pure JavaScript conferences. So thanks a lot, and hope to see you partner and enrich the ecosystem of these universal frames. Yeah.